Welcome to the SEG Europe Regional Advisory Committee's webinar series, State of the Energy Industry in Europe. Dr. Adriana Ramirez, Chair of the SEG Europe Regional Advisory Committee, and myself, Lori Weitzel, will serve as your host for today's webinar. Before we begin, the model for this webinar will be a short presentation, followed by an extended question and answer session. That said, we will also accept questions as we go through the presentation today. If you'd like to ask questions, please raise your hand in the webinar interface, and I will adjust your settings to allow you to ask your questions directly to the presenter. If you do not have audio, please enter your questions in the chat. Our presenters today, our first presenter will be Rune Hegland. He is the General Manager at DECO. Rune has more than 20 years in the seismic industry. In 2011, he left Raxar to start his own consultancy company and has worked on several smaller and larger projects, primarily of which have been developing SEG-Y and SEG-D format checkers for Troika International. He has, in parallel with the development work, been involved in international data standardization since 1996. He has served as chair and vice chair of the Society of Exploration Geophysicists Technical Standards Committee from 2008 to 2013 and served on the OGP Geomatics Committee and Energistics Standard Development Team for several years. He has been involved in the development of many standards, for example, SEG-D Revision 1 and 2, P1/11, and RES-QML, but also authored standards like SEG-D Revision 3 used in seismic field data recording. Received in 2014 the SEG Special Commendation Award for his work. Our second presenter is Stewart Levin. He's a senior research scientist at Stanford University who has just retired. Dr. Levin has over 40 years of experience in research and development of geophysical data processing and analysis for oil and gas exploration technology. A retired Halliburton Fellow, he is currently a senior research scientist at Stanford University Department of Geophysics. At Landmark Geophysics, he had been the development lead on ProMax seismic processing software family, developing new geophysical algorithms for noise attenuation, filtering, and imaging of seismic data with special focus on 3D data. Dr. Levin has more than 100 technical publications and presentations, is an innovator on 8 U.S. patents, served as chair of the Society of Exploration Geophysicists Research Committee, technical program chair of the 2010 SEG annual meeting, and was the first chairman for a day at Halliburton. He is a member of the SEG Research Committee and Technical Standards Committee and is co-editor of the most recent SEG-D and SEG-Y seismic formats. Our third presenter is Jill Lewis. She's General Manager and CEO of Troika International, Ltd. Voluntary positions that Jill has held. One was past chair of the technical standards of the SEG, having led the team that brought about the ratification of SEG-Y Revision 1, SEG-D 2.1, SEG-D 3, SEG-D 3.1, and SEG-Y 2, all of which are now in use. Jill is also liaison between SEG, Energistics, and IOGP. As managing director and CEO of Troika International, she has been able to drive a new approach to data management supplying the industry with systems to automate contract and format compliance. With over 6,500 licenses deployed worldwide, the ability to QC over 180 terabytes of data per 24 hours, this technology is now part of the fabric of data management worldwide. So without further ado, let's please start the webinar. Take it away, Rune.
Okay. Good evening, or good morning, as the case may be. So, my name is Rune Hegland, and I have been working together with Stewart, who's the primary author of SEG-Y 2, written this new standard, and we'll go through. We will go through it in from a little bit of a high level, really, but we will delve into the details necessary to get some points across. So we called it SEG-Y is dead, long live SEG-Y. This is basically a hope to get some new ideas into the seismic processing environment, and basically present the ideas of what was the driving forces behind making a new SEG format. So we will present an overview of SEG-Y2 without going into too much technical details. However, as we move along, I ask you to raise your hand and ask questions if you have questions regarding the issues we're discussing just now. If you have other issues, I suggest you wait until the end. But so we can cover the different issues as we move along. So let's start with what is SEG-Y. I presume most of us are in the oil and gas industry, so we know what seismic data is. So SEG-Y initially started as a way to store seismic data on tapes back in the 70s, 1970s. At the beginning of computer industry, basically. There are some standards before SEG-Y, but this was the first really successful attempt that's been living for a long time on storing seismic data. And that we can read data from 40 years ago is, to me, a big success. So it started as a way to store seismic data and has now moved into other industries as well. So basically, it is used to store any kind of data, especially on the oil and gas industry, that can fit inside the format. So it doesn't have to be sound data, it can be electromagnetic and gravity, for instance. And also it has moved on to disks, of course, and other media like USB memory sticks and that kind of thing. So it started as a very simple format and has become quite complicated and been used in many areas where it initially wasn't intended to be used. And this, of course, causes challenges. The thing to note here is that it's supported by hundreds and maybe thousands of software packages, from freeware software packages like Seismic Unix, and to large and extensive data processing packages with the huge expensive licenses. So also what is important to note here is that it not just describes the organization of data, but it also describes how the data should be mapped to a physical media, basically how it should be stored on tape and how it should be stored on disk. So if you go to I've put up a few links here. The technical standards themselves, all of them that's provided by SEG, it can be found by seg.org/ts. This is a short link that links to a little bit longer link below. The link above is technology independent, so if it's moved around, you can always come to the technical standards by adding /ts. And the Technical Standards Committee has a similar short TSC. The Technical Standards Committee is the one that's responsible for further development and maintaining the technical standards within SEG. So if you have questions regarding technical standards, you should contact that committee. So just briefly, I think this is quite important to know. The reason why SEG-Y is organized the way it is due to the way tapes were organized back in the 70s. So this basically just gives an overview. BOT is the beginning of tape, and information that's stored, data that's stored between end of file marks are thought of as a file, and this is a SEG-Y file is one of them. And each file is split up into blocks. And a block is the smallest part of data that can be accessed on that physical media. And this also applies to modern disks, for instance. They're also divided up into blocks. And a tape will consist of multiple files and then terminated. You often buy two double end of file. So as when you read the file that's 0 length, you know you're at the end of tape. So I just basically briefly put up some definitions here. So a file is basically a group of data that has a set of common parameters. And a file header is a data block that describes the file, and then samples, data samples, is called a trace. And a trace has a trace header at the beginning. So the seismic data was initially made back in the SEG-Y revision 0, as it's referred to, was published in 1975. It was revised in 2002 to basically incorporate data, a new type of data that was coming along at that time. And also we added some metadata describing data. So it was possible to store extra information about the data in the files. This has not been much used, but it's there. Now, then the SEG-Y 2 was revised in 2017, and that's what we're going to discuss today. There are major changes. However, it's still basically backwards compatible. So I don't think we should dwell too much into the technical storage formats, but what's important to notice here is that there is a real identification header, which is referred to here, that describes the data that's going to follow, and then the samples from each receiver or is following, and it's all separated by a block gap. This is important to note. This is how SEG-Y revision 0 was done. On SEG-Y revision 1 is basically the same format. However, we have added what we call a tape label. This isn't used that much, but it basically makes it possible to read the data more efficiently if it's there. You can specify how large the blocks are, so you can read much faster. And then we have a file header, and then what I refer to as the extended metadata that will describe the data that follows, and then follows the traces, which has a trace header and then the data belonging to that trace. So why did we need a new format? In 2006 or 8, I think, we started working on improving the storage of field data. And basically that was to accommodate the new equipment that was being made in the new millennium. And those data had sample rates that couldn't be stored in SEG-Y and sample formats sample data that couldn't be stored, and lots of other technical issues. So basically, SEG-D field data cannot be stored in SEG-Y. So field data cannot be processed. That is a bit of a problem. Also, there were very little room for non-standard trace information, and Stewart will come back to that later on. But because the technical development also took place in the processing industry, you needed to store much more information with the trace data. And that was basically not possible within the standard. So different companies made different interpretation for their own technical reasons. So SEG-Y 0 and 1 can be referred to as not a standard. Basically, everyone is making their own interpretation of what that means. So this causes no end of problems when you try to process data. Basically, you need to figure out how the data, what format the data is, and then interpret that. This slows down the process a lot and makes automation and all of these things almost impossible. So in effect, only the basic data, you know, the number of traces and the sample values themselves were standardized. Everything else was up for grabs, basically. Also, another issue with the SEG-Y 0 and 1 is that people SEG-Y 0 and called it unused SEG-Y 1 features, like sample types that was not available in SEG-Y 0. And this, of course, also caused problems. One of the really, really big problems with SEG-Y 0 is very low performance on modern tape drives. So it is not uncommon that it takes days or more to read a tape in a processing system. This is quite, basically, if you look at this is a figure from an article that we wrote and was written in August 2015 of the Leading Edge. So it's available. Basically, these are numbers from the manufacturers themselves, and also tests done at, for instance, CERN. What performance you get out of different tape drives based on block sizes. Because in SEG-Y 0, a trace is a block, and the way processing works is that you basically only take out the part of the trace that contains important information, and then maybe resample down to 4 milliseconds. So a trace is very short, maybe just 4 kilobytes. And if you look at this figure, you will see that even on the most modern tape drives that can read hundreds of megabytes per second, when you get down to 4 megabytes block size, it's basically only 20 megabytes per second. And if you look at a 10 terabyte modern tape, if you read it at 20 megabytes per second, it takes almost 6 days. This is one of the biggest pillars of SEG-Y 0, and one of the things that we had to address with SEG-Y 2. And even though SEG-Y 1 has support for large blocks, it's rarely used. So it could have been used in the same way as SEG-D implements multi-trace blocking and had basically high performance, but it was never really used. So off to SEG-Y revision 2, and I will leave this up to Stewart. So take it away.
Oh, it can be the screen. There we go. Okay, so this is Stu Levin here. I actually retired from Stanford. I'm 65 on Friday. Saturday, the check engine light goes on my car. Yesterday, turns out a spoke is broken on my bicycle. My first day away from work, I'm up at 4:20 in the morning. Yeah, that's a good retirement. All right, anyhow, let's move forward here. I prepared just a few slides, pretty high level after 40 years in the industry. It makes sense to do that. And I'll go, come on, move screen already. Well, we'll get there. Go ahead, you can do it. There we go. So we developed the standard over a course of about 5 years, starting from a proposal, then working through multiple drafts, getting a lot of feedback, incorporating many, but not every possible suggestion. We'll be getting to some thoughts around that at the very end. And then finally got it approved. Let me go to the next slide here. Eventually. It seems large and scary only because it's about a 150-page standard now. But in fact, there's not much new that has to be implemented, and I'll actually have an example in the slides, which we'll probably skip over at the end, but it took me about 2.5 hours to take the SEG-Y write program and create a SEG-Y write 2 that was actually readable by the existing SU system and still compatible with SEG-Y Rev 2. All right, now I've got 3 slides. If you look at nothing else, these 3 slides are important. So there are 3 audiences we are trying to address with this presentation. The data manager, someone who has to keep the data, move it around, archive it, et cetera, and key things are the format is self-defining and extensible, so we're not limited to 240 bytes of trace header. We can put all the in-house parameters you ever want in as part of the metadata as self-defining, so that whatever your definition is, you can use it. We've got additional numerical options, so if you're using, say, EM or some other type of data that requires higher precision than single precision float, you've got it. We've done our best to keep it compatible with SEG-D's choices of coordinate reference systems, things like that. We are leveraging external standards. There's no reason for us to define brand new units of measure, things like that. And we have attempted at least to streamline the process of getting new things into SEG-Y without having to go through a whole 5-year process like we did before, that we can put in at least small changes fairly quickly and not have long delays. And then finally, for those who really want to have performance coming off a tape especially, you can actually write it in what's called Little Endian, that is the native formats of the PC, the Intel chips, and that's important for high-speed tape streaming. So that's for the data manager. For the practicing field and experimental geophysicist, you can define exactly what's in your trace headers. In fact, you have to basically define what's in your trace headers. You can map and remap the existing trace headers. You can add new trace headers, and it's all documented with ordinary text. So just a quick look at the file as a text, you can see exactly what the layout was of all the different trace headers that were defined. Those that you don't understand, you'll skip, or you'll call the person who did it. You've got lots and lots and lots of room for additional trace header information. You can append at the end any arbitrary notes or even beforehand, and processing history and so on. And thanks to my pushing for 5 years, velocity and anisotropy grids are now first-class citizens. You can do that. So a lot of things that, as a processing geophysicist at least, that's useful. Experimental geophysicist, I work with Shuki Ronan at Stanford. He does a lot of experimental field stuff, and they almost always have been using SEG-Y, and I'm breathing a sigh of relief that they can put their their new and novel experimental trace headers and trace data into the format. And the third very important slide, if it gets there, is for the software developer. So there's a big investment in software for reading SEG-Y, writing SEG-Y, and I just want to assure that, yeah, there is some work to be done, but there's a high degree of backwards compatibility. As I mentioned earlier, I was able to take the seismic Unix freeware system and make it SEG-Y Rev 2 compatible in about 2.5 hours. You can, there's not a whole lot to do, and there's just a little checklist of stuff that can be done. That's all that's needed. One of the nice things is that when you remap the trace headers, you can use names, you can use byte offsets, whatever you want, and you can actually now have flags only like 40 years after SEG-Y came out that says, here's the end of the line, here's the end of the gather, here's the end of the data, a flag in the trace header for that, which makes things a little bit easier for anyone else. As with all the previous versions of SEG-Y, you can just skip over parts in the that you just don't understand, and you'll be okay. And finally, there's, for the purposes especially of automating machine automation, you can provide and generate XML-based metadata in the formats that with the contents you want to include. The SEG is not defining a specific content for that. We're defining what's called the semantic, the syntax, and you define the content of the semantics. All right, let's see if that works here. Okay, so SEG-Y Rev 2, as I said, just like the other one, has pretty much the same sort of look as if it goes to tape, but there's more trace headers and more textual file headers, and there's a data trailer where you can dump anything, including navigation, processing history, and so on. Almost there. So just going back, there's a lot that was requested for SEG-Y 2 over the course of that 5-year development. This is what was requested, and I'm not going to go through the list. The presentation's available, but it has a lot of things that people expected: long traces, a lot of control on timing and sample intervals, ability to incorporate other stuff so that you kind of have everything in sort of one place. What we actually implemented was, there it is, everything except encryption options basically showed up in the standard. So you've got what was requested. And I believe the next slide, I think I'd like to turn that back over to Rune if possible.
Okay, I can take these next 3 slides. So what was observed that was the problems of moving data from the field into processing and between processing stages. So one of the major focus points of SEG-Y 2 was automation. And the slides, okay. So how this has actually become more and more relevant, but we wanted to have, in theory at least, the ability to move data directly from the field into the data processing, and then out from data processing in the field and into the office automatically without any human interaction. That was sort of the dream. So machine reading is very important, machine learning, data mining, automation. These were sort of the theme words when we made this new format. Basically, the crucial part is space for information. So we needed to set aside much more much more space for meta information, or the information that describes the data, describes how it was acquired, what has been done to the data prior to this stage, and then what is going to be done, what parameters are going to be used, for instance, and what algorithms are going to be used, and what the output data will be. And then we needed basically an overall description of the file, of the data. This could be, you know, the processing database, or just the parameters. But after lots of discussion, we couldn't come up with a solution that sort of described how this should be done. So we needed to let that be up to the users of the data. So we set aside, as Stewart said, a lot of space for what is an XML wrapped, if we said XML based. It's basically just the description of each block of data is done in XML, and then the data itself is any data you can imagine putting in. So you can have any number of data up to, I think, about 6 terabytes of data in as a SEG-Y file that describes the data. And this could be like processing logs, parameter descriptions, quality control information, position files, raw field data, different types of logs. Even the entire processing database can be wrapped up and stored with the data itself. So the SEG, we felt we couldn't really standardize on what this should be. This varies too much and will vary a lot with technology as it's being developed. So that our thinking was that companies or government organization, or whoever you would like, need to specify what automation should be necessary within their domain, and what data is necessary to store to achieve that level of automation or machine learning they desire. So this is something that will have to be worked on down the road, now that we have the format to store that information. So to note this, there were some effort to be standardizing, for instance, the text that's stored in the beginning of a SEG-Y one file. And for instance, the NPD Yellow Book specifies a bit how this is done, what should be there, like line names. This will help a lot when you do processing. However, lot more need to be done. So as I said, this is now, I think, up to the government and contractors and different asset management and whatever is to specify what need to be done. What we would like to achieve is basically so that you get a SEG-Y file and it can be automatically loaded into your database. You can easily determine the contents of those data and what has been done to it. And then there is no longer a need to repeat the tasks. For instance, when you get to the office, you don't have to redo the tasks that was done in the field. For instance, muting bad data and spike detection and all of these things. It's all stored in the standardized way. And then field and office processing can cooperate without a problem. That was sort of our thinking. And this will save a lot of data and make quality control of the data a lot easier and better. As I mentioned earlier, performance was a big issue with SEG-Y, and still is a big issue with SEG-Y. So we didn't change the format of SEG-Y too much to maintain backwards compatibility, basically. So if you want to store the data in pure SEG-Y, which many contracts specify, you still need to use the tape label that has been there since SEG-Y 1, and then specify the block length and write multiple traces per block, similar to what the field data has been doing since 1997. This hasn't been done in SEG-Y because it's sort of an offline job, processing, and then you don't really need to consider performance that much. But as we now see, the size of tapes and the size of data has now grown so big that not doing this is not really an option anymore. The second option, which SEG-Y provides, is that it can be wrapped in a format that has larger blocks. And this SEG provides the ROAD format that can be used in this case. There's a lot of other formats, and the user can pick whatever it likes. But this must be noted that it's not pure SEG-D, so it might break the contract of what the delivery from the field or the processing company should look like. And also it will probably break many government specifications. But for performance, these were the two options we ended up with. Next, I guess I can do this one too. There has been lots of questions about what do we do with SEG-Y and the cloud. Does SEG-Y support being stored in the cloud? And the short answer is yes. SEG-Y can be stored on disk anywhere, including in the cloud. The thing to note in that respect is that this is not so much a technical issue as a legal and contractual issue. When you store things in the cloud, it's basically like offloading your IT department. You know, you send your data to another company somewhere in the world, and you need to know if this is legal. Does the government allow you to transfer this data outside of the country and region? It is stored in an unknown format and backed up in an unknown format. How do you deal with security and recovery in the cloud? And also longevity. SEG-Y data, as we've seen, has been available for 40 years. Will this cloud you select be available in 40 years? These are questions you need to ask yourself. But this is not a format specific issue. This applies to any data you would like to store in the cloud. And then if you answer yes to these legal issues, the contractual issues, then you have the technical issues. You know, these are petabytes of data. So you need to transfer those data in and out of your company. Or maybe you store your algorithms, your processing algorithms, in the cloud as well. Do you want to expose your technical solutions to be out there, or do you want to keep them inside your own company within your firewall and protected against industrial espionage and all of that stuff? These are questions you need to answer. So in the article we referred to earlier, the future of TASE and seismic, there were some discussions regarding the cloud. I suggest you read those as well. But the answer is SEG-Y ready for the cloud? The answer is yes. Technically, at least, yes. So I think I'll leave these ones, go back to Stewart. So I think you take.
Okay, I'm back again. I see there's a question about moving data automatically. have to hold off on that for just a couple more slides, and then we'll open up that one for the discussion. As said, backwards compatibility is certainly an issue with any new standard, and we did our best to try to keep as much as possible your ability to read and potentially write the older versions of SEG-Y and still be handling SEG-Y Rev 2. And as said, these slides will be out there, so I'm not going to worry too much.
So yeah, I'm back as well then. Let me see. From the field, for me, once data gathering is done, once the quality of data tested, we should apply many algorithms to solve some problem. Is this correct? Yes. So the job of processing doesn't really change with SEG-Y 2, right? It's the focus was to make it easier to. A SEG-Y is an exchange format. It's not the data model of a processing system. There's lots of other stuff going on inside the processing system that's not described in SEG-Y. So when you exchange data in SEG-Y, you sort of need to describe what you've done to them. That's sort of the clue of SEG-Y 2. So real-time algorithm and the different types of algorithms is not that. That's not really. You need to describe what has been done to the data. How the result you have, what is it, and how did you achieve them, so that you can actually take the raw data again and reapply those algorithms and get to the same point. That, I think, where sort of the crux of SEG-Y 2 ID, you know. Does that answer your question? Because SEG-Y itself shouldn't define what the output should be. You know, that's up to the systems that's using it. It just needs to be described. What's the uptake of SEG-Y 2? That's a very good question. I don't think I'm the right guy to answer that. Jill, any, and Stewart, do you know?
This is Stu. As far as I know, I've gotten only a few questions so far, and several emails that said, hey, you did a good job, very nice. Whether they've implemented it yet, I don't know. I've been off in academia for a few years, so I don't get on top of what's happening in the field.
Yeah.
As far as we're aware, Saudi Aramco have certainly implemented it, and at last year's SEG, they asked to engage with other people, but although we've tried, they haven't been as forthcoming as we hoped. The various national data repositories around the world have also looked at it and said that they wish data to be reported in that way, but they understand that they haven't really been as forthcoming as they might be with regard to what the metadata should actually contain. So I think the next phase of this will be to take what we can away from here and try and tighten up on advice as far as good implementation is concerned. And certainly we are seeing it come into contracts, which handshakes with national data repositories, of course.
Yeah, I think that's the clue. It's even if the uptake is 100%, it doesn't really matter until you get the proper metadata in that supports the functionality you would like to have using SEG-Y 2. So it starts with getting it implemented, and then it continues with specifying what metadata should be included. Yeah, it's the early stages. Yeah. And then it's a question about using SEG-Y for non-seismic data such as gravity, magnetics, and EM. I know there has been a little bit of use in the EM area and also gravity. However, this industry hasn't been doing that well over the last few years, so it sort of died away, I think, there as well. I don't know if any of the others have any more information about that. Yes, can we get assistance from SEG to specify the metadata? Yes, is the answer to that. However, so SEG should be able to provide the technical help to specify metadata. You know, how it's done, what it should look like, you know what. But I don't think SEG is the right group to specify what the metadata should contain.
Sorry, at the forthcoming SEG Troika, who historically for both SEG-Y, Rev 1 and the SEG-D3 ran a sort of email reflector, very, very simple system. You could just use a common email address and comment into a group of like-minded people. We're going to apply to the SEG at this forthcoming conference to set the same thing up for SEG-Y2 in the hope that there'll be a forum people can easily comment in and sort of develop against what hopefully will become recommended metadata standards and standards.
Yeah, this is actually a technical issue with SEG, which has frustrated us over the last couple of years, I think, is that exchanging information within the technical standards committee has become quite difficult with the new technical solution they have picked. So we need to do something there. But the short answer to can you get assistance? Yes, absolutely.
We have Arvid who would like to ask a question.
Yep.
Yes. Can you hear me?
Yep.
Okay, this is actually Stephen Eames. We're both from Stavanger, working with ND's NDR. I have a question in regard to the implementation of SEG-Y revision 2. What we've seen here is the main showstopper for us is actually the internal applications within the client's office, the betrayals, the size works, because they can't read the files, and the uptake to actually use SEG revision 2 is really depending on those applications. So have you had any contact with the software companies to actually make sure they update their applications?
The users of software, of course, need to specify what they like supported in their tools. So you need to ask for it and possibly put it into contracts that it should be implemented. And not just SEG-Y2, but maybe interpretation of this and this kind of metadata as well.
But that's
Sorry. I was going to say, we tried incredibly hard to work with not only OpenWorks, Betrayal, and all of the other applications. We went around SEGs, talking to people on stands. We begged them to come to meetings. And I'm afraid to say that a crowd of people interested in updating a format was just not particularly on their agenda. So unless the national data repositories and the major and super major oil companies say to these people that they, you know, require this to take up both future purchases and support, it's just not going to happen. So the drive has to come from the industry for that to change. They've got no reason to spend the effort otherwise.
No, I agree completely in that. And Eric, that's up to you, sort of. That the NPD specify that, okay, you need to deliver the data in this and this way, and then the users of the software packages seems they need to ask for it as well, and then I'm sure the software companies will provide. But until that happens, it won't, basically. And
the challenge you have is that we have our own internal working processes, and here we're using scripts and programs, and I'm not sure I agree with Stuart. I think updating to support SEG version 2 is a bit of a work to be done on the software side. It's not a trivial task. You've got to know what you're doing, and then you've got to spend time updating the software.
yeah,
So,
so
I mean, the actual format itself is great, but actually implementing it is a challenge.
yeah, no, as Stuart described what was minimum required to make SEG-Y 2. Right, but that's not, we are now talking functionality and maybe serious pieces of functionality as well, and that of course is not easy to make. So this is where, you know, the NDRs and that kind, those the larger companies need to specify what they need and want, and then need to do that in a way that is possible to achieve as well. So the last point in this slide, which you see now, you know, it needs to come from the users of the data, not from SEG is the technical standards committee makes the standard required by the industry. It doesn't really specify what the industry should use. So I think it needs to be a focus from the major oil companies, and if you want to have more of an international drive in this, it sort of needs to be sponsored and supported by good people, and maybe run it even through SEG, if that's politically easiest way to do it. Then definitely the SEG will support that process. But as always, as it did with SEG-Y 2 and SEG-D3, the drive came from the industry needs. And for instance, in the case of SEG-D3, it came from the instrument manufacturers that needed to store the data they actually acquired. Hello. Did anyone have a question?
Timur, you are unmuted. Do you want to ask a question?
I see Arvid Lillevik.
That's still me, I'm afraid.
Yeah, and Timur Hassan.
Any more questions?
Yeah.
So I think one thing that would definitely help with implementation of SEG-Y version 2 is to have data examples. Actually have data sets out there, all the different combinations and all the extra functionality. So that means the software developers can then test them. So it's impossible to actually get hold of a SEG-Y version 2 today. In addition, what about having code as well available in Python that's already been coded?
This is Stu. Now that I'm actually retired, I can finally get around to that project. But that is part of the forward plans for SEG-Y Rev 2, is to get some data examples. And I'm a software developer, so I will write something that is fairly comprehensive for let's call it syntax checking.
Yeah.
And potentially, since the SEG now has HDF5 as approval and licensing, a SEG-Y input to HDF5 database example.
Well, yeah, this is a very important issue and part of the process. And what I think, like IOGP has done quite well with the new P1 format, you know, provide examples and validators. So, but of course, the difference between IOGP and SEG is that IOGP is a sponsored group and the SEG is based on voluntary work. So that's where the support needs to come from the oil companies and the government organizations that wants this to happen. And there will be some money needed to actually provide that. And I know Stu will do a good job in his retirement, but I'm guessing there might be more needed as well. And also to promote that information around in the world requires some money and some effort from someone. I see Anthony asked the question, are there any software tools available from SEG or others for reading these formats? And then I guess Stewart has sort of answered that. Seismic Unix, for instance, will now support SEG-Y too. So that's one example of a software tool available.
I have a question about the history. So what was the beginning of SEG-Y standards? Was this an idea of a single individual, a set of volunteers, or industry-driven, academia-driven? How did it all start?
There. I leave that one up to you, Stu, and Jill.
Okay, you're fading out a little bit, but this is Stu. Basically what happens is I was, among other people, I had to develop software for Promax to handle different input SEG-Ys, and it's a nightmare because there are many different flavors and formats and so on. And so I went and complained to the SEG Technical Standards Committee, and next thing I knew, the person who complains is the person who's now volunteered to try to fix it. But it came from many, many instances, myself and many colleagues who were like, oh my God, not another SEG-Y with, oh, they're writing this over here, they put this in Little Indian over here, I can't read this thing, what do you do? So I was very selfish myself and said, I want to make something happen so I don't have to spend all my time figuring out the 70% of the time that's spent trying to read data in and figure out what's in there. So it was driven by the nightmare of unspecified and poorly specified SEG-Y files that were already out there.
Thank you, Stuart. That's great. That's a very good story. In the future, what would you say that, where would you say that we can or we should be focusing on new standards? Do you have any overview or any thoughts around that area?
So I made this slide here yesterday about where do we go from here? You know, do we continue with SEG-Y or do we make something new? We have sort of been discussing SEG-C over the last, just as a term, as a label, a name to put on it, and basically combining the field data and the process data. This makes, to me, a lot of sense because the way the seismic field works today is that there's lots of processing in the field as well. So separating between what is field data and what is process data is sort of artificial. The thing is, you need to have support for the data types and the data formats of SEG-Y, but with support of field data metadata, you know, the instrumentation information as well. So then, of course, we should think a little bit new, make it 100% machine readable, self-defining and self-describing. And we have been discussing this a little bit. And I think the conclusion, and others might object, is that this is probably the best technical solution, but the industry has invested a huge amount in seismic data format readers. You know, there's dozens of SEG-D field data writers and readers, However, there's hundreds of SEG-Y readers and writers. And I just saw a number somewhere some years ago that $100 million was invested in this seismic data readers, writers. Do we say to the industry, throw away all of that, those investments, and make something new? As maybe another $100 million. Will that idea even take off? And I have a feeling that no, it won't, unless someone really powerful, i.e. the government and large national oil companies and major oil companies, says you must do this for this and this reason, to make it more efficient, to save lots of money down the line. Until that happens, I doubt it will happen.
I think the other thing that we need to be very, very aware of is the fact that SEG-Y has been successful, and that we're an industry that relies on information no matter what the current computing fashion is. The reason we can read our data from so long ago is basically these are binary formats. And to move away from that and become embroiled in whatever the computing world is doing at the time would endanger our ability to read this data in 40 years' time. I'm aware of a project whereby Shell is currently refreshing data from the late 60s because of the advent of fracking. They didn't think that information was going to be really of any use, but they decided to keep the old analog tapes. Now they've become invaluable because they're in areas that it's very hard to go back to. So I think we need to be very, very careful what sort of update we carry out if we're going to do a blanket one of some sort.
Yeah, and I think tagging on to that, the reason why tapes have been so successful is that a tape is just a stupid foil with magnetic stuff on it. If we start to involve, you know, discs with electronics and that kind of thing, you know, that technology dies quite quickly. Who can read a disc that was manufactured like 20 years ago? So as an exchange format and a storage format, SEG-Y has been very successful. And choosing where to go, we need to be very careful. Okay, Stewart, do you want to present the previous slides?
No, I just slid by them so people could just take a quick look later when they download the PowerPoint. In a couple of weeks it'll be available.
Yeah, good. Yeah, I think that's a good idea. So, okay, then final questions. So I would like to say that, okay, the SEG Technical Standards Committee, and the chair there now is Victor Ansira. You should contact him if you have questions about SEG-Y and any other formats, or would like to start sort of a group that looks into specific areas, maybe a specific kind of metadata that you would like to have included in SEG-Y. I think that's a good way to address these kind of issues, because different areas of processing and different types of structure and data will need to have different metadata. So I think having a separate committee team working on that might be the way to go. And then Victor is the guy to contact. He's on the available in this webinar if you have questions to him as well. Otherwise, I can be contacted by this address. Stewart and Jill are also available to answer questions if you have them. And if there's no other questions, I'd like to say thank you.
There was actually one question. It was a they say it's a very basic question, but can someone tell me what is SEG-Y?
The SEG-Y is a name. It's a discussion theme we had because we realized some years back that SEG-D and SEG-Y doesn't really fit the purpose anymore. It made sense back in like the 70s, 80s, maybe 90s as well, when the field was very much separated from processing. In the 90s, late 90s, early 2000s, processing moved onto the field, both in land and marine. So having field data, delivering field data from the field without processing information seemed silly because the data had been processed. However, you couldn't use SEG-Y because it lacked the support for the meta information you needed to have proper quality control and historical storage of field data. So then we started discussing, shouldn't we make something new? And the term SEG-Y came up. And that's basically all it is. It's just a name and a potential coming format if the industry wants it. Nothing else.
Okay. There's one more. If you were to give numbers on the costs that SEG-Y standards have saved the oil and gas industry, is there a round number that you guys could give about the efficiency that the standard helped save the industry?
Round numbers in billions. Now, this is an industry that spends lots of money, right? So I don't know if Jill is maybe a good person to answer this question. Maybe Stu as well. They are working in the processing area. But I know it's a lot of money. It also has cost the industry a lot of money. So, yeah.
If we did not have a way of exchanging data and being able to read each other's information, we would not have been the successful industry that we've been. It would have had just such an incredibly dramatic effect. Prior to SEG-Y, there was a protectionist attitude whereby people would write formats according to the system that they were working on, the system that they designed, and basically hold data to ransom. So to return to those days with the complexity of the oil industry today would cost us an absolute fortune. So therefore you could say that it's probably saved us literally trillions, just a massive amount. It would be impossible to operate without it.
All right. Well, there are no more questions. So I guess we're done. So thank you, Rune, Stu, and Jill, and thank everyone who attended the SEG Europe Regional Advisory Committee's webinar as part of our webinar series, The State of the Energy Industry in Europe. Everyone who has attended, please be sure to respond to the follow-up webinar email. Tell us what you liked, what could have been done better, and suggestions for future webinar topics. So please look for our social media posts for next month's interesting webinar. Again, thank you all for attending. Thank you, Rune. Thank you, Stu, and thank you, Jill, very, very much.
Okay, there's another question here, I see.
Oh,
which is a very good one.
Okay.
So where can we find and use SEG-D, Y, and Z? Z doesn't exist, so you can't use it. And how can we contribute as a member of SEG chapter? This is a very good question, and here, Victor, I guess you should answer this question. But contact the Technical Standards Committee, see if there's teams you would like to participate in. The Technical Standards Committee always looks for good people. Also, if you would like to start looking into a specific issue, then starting a new subcommittee is the way to go. But contact Victor. He's the guy. Oh, he's got mic issues. So if you contact him at this email address listed here, you can be added to the technical standards committee, and yeah, he will take it from there basically. Okay, Mustafa Seba. That was a very good question. Okay, thank you.
All right. Thank you all very much.
Thank you.
Bye.
Bye.